I'm Jason Tucker, and I'm basically working within the cloud services for a company called SAS, and we do analytics software development company based out of Cary, North Carolina. And we are going through a journey, and that journey is to cloud native technologies. Now, I'm personally in IT, and we've been working within Kubernetes for a little while now. We actually started through OpenStack, and when we were going through OpenStack and trying to figure out how we could get the system itself deployed and supported without anybody being woken up in the middle of the night, Kubernetes was the answer. So because we've been working through this for a little bit now, we came up with a few tips and tricks, and that's why I'm here, is to share what those tips and tricks were. And we actually have those available to you on our communities page. So I'd like you to take a look as we go through these. If there's anything that looks extraordinarily interesting to you, there's a link here that you can just pull that information down and get all the gritty details. So what I'd like to do is start off with why EKS and what makes EKS a little bit different and how we can get a benefit from it. Now, when we're working within operations, you know the simplistic method of using EKS. Really, you just go to the interface, you click a few things, you set up an IAM role, and you have an EKS cluster running. You define what it is that you want from your nodes, and you're good to go. So we found that that was very easy, and we also found a benefit from that. We found a benefit from EKS in addition to the simplicity, but we also found that we can access GPUs very easily as well. Our software leverages GPUs with some of the modeling that it does, so it's an extraordinary benefit that we found. And one of the kind of maybe possibly downsides, if you're looking at it from an operations standpoint though, is you have to be careful about the versioning. The versioning of EKS for Kubernetes right now is 1.14.7, unless I checked. And Kubernetes itself is on 1.16.3. So if you need to have those latest versions, then you might want to roll your own on that one. But EKS also gives you global deployment. And this is really where we saw a huge ability to deploy to the world very cost effectively. We were able to take a region and stand it up with a very small footprint to get started, and we were able to roll that just right away, get our footprint out there. And we also saw a reduced cost because of that. And I'd like to talk to you about some deployment optimization. So we have analytics software, and analytics software performs some pretty complex calculations, as I'm sure you're aware, and it also leverages some very large data. These are some interesting circumstances that you have to work around when you're dealing with containerized technologies. So the first one that we did was we came up with this concept of idling. Now, if you're looking at your software use, you're looking at your containers and your pods as they're running, chances are somebody might not be using them right now if it's an interactive session. So within the analytics space, when you're working through modeling and you're working through some workloads, it's very important that you have that running and you have that running right now, but then when you walk away, it's not so important. So what we asked ourselves was, how can we take and realize the benefit of the cloud, but not interrupt the user experience as well? So we came up with this concept called idling, and what we do is we create a pod, and that pod looks for metrics that are built within the running containers that we have deployed for our workloads. And those metrics, they're pulled in, they're pushed to a central location, which is the idling pod. And when it's determined that that pod is no longer active and the person might have walked away, we shut it down. Well, you can imagine also that if you shut that pod down, when the customer comes back, they're going to be kind of rudely interrupted with maybe a 404 error. So we took care of that, and what we did was we did an actual interrupt to where we can take that user as they're coming back in, identify that they're going towards an idled out pod, and start that back up. But starting it up isn't enough. We also have to put them into a little bit of a holding pattern. But because Kubernetes can start applications so quickly, because it's containerized, we're seeing that we can start that within 7 to 10 seconds, and the user goes right back into their workloads as if nothing really happened. And it's a very seamless user experience. Now, the important thing here is that we personally realized a 50-to-1 concurrency rate by doing this. Taking those application workloads, shutting them down, and not spending a dime while they're not being used, which helps us tremendously. We also have, if you're going to the communities page in this link here, you can see that you can plug in some different application idling parameters as well. So it's modular to whatever your workload might be. The next part is preceding applications. Now, some of you might have a workload or an application within your environment which doesn't necessarily fit the size ideal parameters of containerization. So if you have that situation, you also know that when you have that user coming in or that need for that application to start, it can take a little bit of time if that node has not cached it. Now, it also could take a little bit of time if you have a CI/CD pipeline that's going to be updating that container on a regular basis. Each one of your deployed nodes needs to then cache that information before it can start that pod back up. So these containers need to be on that node before the customer needs it. What we did for this was we took it's actually a daemon set. The daemon set runs on each node, and it looks within the config maps of all the deployments, determines what containers are needed and the labels. So that's how we can get by with the CI/CD. As soon as we have the pipeline pushing a new container image, it updates that config map and we can see it. Then what Cedar does is it pulls those containers down and caches them on every single node that's running in production. So we're not wasting space either. We have Cedar that's only caching it on the nodes that are in the clusters that need it for those deployments. So we're seeing that the users are able to spin up their environments very, very quickly because of this. Now, what about security and policy management? When we're working through cloud technologies, we can't ignore security. Security is a part of our daily life, especially in operations. We have to work through how we can make it as secure as possible. So there's a couple things that we did for this. Now, the first one is an egress controller. Now, we're probably familiar with the ingress controller. This is the inverse of that. The ingress controller allows any traffic coming in to know exactly where it needs to be, directs it right there. The egress controller gives us a layer of security. We don't want all unfettered outbound access to the internet from our clusters. We don't want this for a couple of reasons. One, we don't want any sort of compromised situation to occur to where now that attacker has access to external tools or resources or can push data out of our environment that we didn't authorize. So to start, what we want is each pod to have an ACL that says this pod is allowed to use these network ports. And that's where it starts. But we also want to be able to control in a physical environment, if we're not running an EKS, to specify which nodes have outbound access. So the egress controller, what it does is it will set a taint on some of the nodes to specify these specific nodes have outbound access. And then it compares the traffic coming through it as a proxy from an ACL that's set on those pods. If it matches, it allows it out. You can also run network security policies, which we do, pod security policies, all a great idea. But this adds that layer of security, and it allows you as an administrator to control what that outbound access looks like. The next one is SE Linux. And if we're in operations, we all love SE Linux, right? Everybody's deployed it. It's fantastic, easy to use. But what we looked at it for was we need to have SE Linux. So SE Linux allows us to take these processes, which are the containers running within the environment, and define where they can run and what data they can access. So we set the SE Linux policy on the volume mounts, and then we set the same context over on the pods that are running those processes. When they match, it runs. If it doesn't match, it can't mount the data, can't see the data. Now, it's also a good idea to encrypt your data. When we're building clusters, we also use encrypted volumes when we mount these containers. We use NFS for that. But this is an extra layer of security that protects you if something does happen to where you compromise it and your data is protected. Now, CMDB, the configuration management database, is a little bit different in the world of cloud computing. Now, in the original kind of traditional world that you would have for IT, you would have a large list of all the systems in your environment, and when you made a change to the system, you want to have a correlation change record over in your CMDB. You want to have an incident or event issue that occurs over here to actually trigger and identify it in the CMDB. If you have that environment, you know that doesn't really work with a dynamic cloud pod type of environment that you see with Kubernetes. So what we did to solve this problem was create a pod, runs in the cluster, and it scans and actively looks through every sort of deployment that we have, the namespace, the pod, and then it updates dynamically the CMDB. If we have an incident, we can map that to the namespace, which is dynamically created in our CMDB. Now, I just want to finish up here with a demo. Now, this demo is of SaaS Analytics Cloud, and this is the platform that my team has created, and the most recent use and leverage of the Kubernetes platform, but also it takes advantages of all these modules that we have that we're sharing with everybody through the communities page. Now, when we're going through this demo, I want to show you something that this is going to be explaining how the idler works. On the left side, you're going to see the kubectl command watching the namespace for any running pods. On the right side, I'm going to access my environment. This was recorded yesterday, so my environment was shut off. I didn't have it running. I accessed it fresh. So we're going to see how this works and how long it takes to run. Now, as you can see, I have the kubectl watch running on the left side here. And over on the right side, this is the Analytics Cloud landing page, analyticscloud.saas.com. And it shows you all the applications that we have deployed within Analytics Cloud. And on the left side, you can see there's no pods running. I'm going to open up a new tab. I'm going to go to my environment, and my environment is represented by a namespace. So this is the namespace I'm watching. As soon as I go there, it detected that I needed to go into this namespace. It needed to have a pod running, and that's what that core pod is that you see. Those 7 containers running in within that pod represent the API, the UI, everything you see on the screen right here. And that started within a few seconds. We have our applications. I'm going to launch SaaS Machine Learning. And when I'm going to choose my IDE, I'm going to choose SaaS Studio. When I launch SaaS Studio, you can see on the left side something else pops up. This is where machine learning starts. Because it's cached and because it's idled out, it starts up very quickly, seeing somewhere between 7 and 10 seconds on average for us to start. But please wait while we load your applications. This is the friendly page that we have that shows the user something's happening in the background. It's seamless, same colors. It's very friendly, very quick. And now we have those resources being used that we need right now. So I'm going to run some code. I'm going to run my machine learning algorithms here. I'm going to get my results and my graph. And now I'm going to go back to our landing page here. I can do the same thing with event stream processing. I'm going to launch it, and on the left side again, you're going to see now the ESP pod is going to be starting up. Same activity, it's running. And we have 4 out of 4 containers running now within about 10 seconds, the same way. And this is where I see a Jupyter environment. The rest of Analytics Cloud has data access, and going back to the data that we were talking about with SC Linux mounting, encrypted volumes, this is reflecting that through the NFS, shows me how much data I have, how much data I'm using, and then I also have a team where I can share this environment with all my friends. So those are the tools that we had. If you'd like to see more about these, please come by the booth. It's 2837, left hall here, straight down, it's on the right. And if you'd like to see an extended demonstration of Analytics Cloud, please stop by the booth as well, and we can show you that. But if you go to communities.saas.com, you can see all the write-ups for these modules that we created along with the code, so that if it's useful for you, please go to communities.saas.com, download the code, read about it, deploy it in your environment, and see if it works. You can also communicate with the contributors, the code contributors within the team that produce that. Their links are within the communities page as well. So thank you very much. Thank you for joining. Hopefully we found something that's useful for you. All right?